Hello again, scholars. My visual aids today are a little bit small, so I thought I'd kind of get up close and personal. But we're going to start talking about relations and functions. Now, this actually is not really a complicated idea. Relations are really just pairing of two things together. So when I started thinking about, okay, what's something that I can look at that's had all kinds of different things of pairing together? And the thing that came to mind was Glee, the show. I'll be honest, I don't like it. I don't get it. I've seen here and there. I've watched little bits of it. If you like Glee, that's great. If you don't, oh well. I don't either. But what I have gathered is you've got all these people dating in all these different combinations. So even though we're talking about most of the time pairing two numbers or two variables together, the idea is still the same when we're pairing two people together. So I've gathered that what was his name? Finn, I think, was dating Quinn. Then he was dating Rachel. And then I think he was dating Quinn again. And, whoops. Well, heck, they might as well have done that too. Okay. There's Finn and Quinn. And then again, it was Finn and Rachel. And you had all these people. Little wheelchair guy, stuttering girl. And then stuttering girl started dating dance guy. Heck, Santana started dating Brittany. Heck, Sue married Sue. So you got all these different combinations of these people together. Now, I can't really follow it all. And I need to kind of simplify it for my example anyway. So what I did is I took some of the pairings and put them together as an X and a Y. So Quinn and Finn, Rachel and Finn, Mr. Schuster and his wife, who was supposed to be, I guess, mean, Schuster and that germ girl, wheelchair guy, stuttering girl, Brittany and Santana, and then of course Sue and Sue. So if we look at these strips, we can see that what I've named the X column never repeats. So if X never repeats, we call that relation a function. But look what happens if I switch it around. If instead I call my X's Finn and Quinn, Finn and Rachel, Mr. Schuster and his wife, Mr. Schuster and germ girl, wheelchair guy, stutter girl, Santana, Brittany, and Sue. We can see that our X now actually repeats. Finn repeats, Schuster repeats. Now, Sue and Sue repeated, but that's not the problem. The problem is X repeated. If X repeats, something is not a function. It's still a relation because it's still a pairing of two things, but it's not a function. So what this actually looks like in math, and since I'm sitting close, I decided to do this on paper instead of the whiteboard, is this could actually look different. We could see it as a table, a relation that is not a function. That is a function, sorry. We're looking at that X in the table. That X can never repeat if it's a function. Notice in this table it never does. I've done the same representation as points. But again, if I've got a series of points, I can just look and see if it's a function or not. These x's never repeat, so it is a function. You could also see a graph. Your vertical line test will tell you, by running a vertical line along it, that it never touches more than one point at a single time. Therefore, that graph is a function. Again, it's the same idea. Then finally, you've got something called a mapping. In a mapping, what you're looking for to know that the x never repeats is that there is never more than one line from the x. There can be more than one line from the y, but not from the x. So that makes these different representations functions. Again, I just came up with another example, but here this one's not going to be a function. So again, you can see if I look at my x's, this one, my x's do repeat. I have a -2 and a -2 here. My y's can repeat all they want. Between my x and y they can repeat, but my x cannot repeat. But it repeats, so it's not a function. You can see the same thing if I list the points. The x repeats when I list the points. It's not a function. I graphed those points. Vertical line test would fail right here where these 2 points are. So the x repeats. And now in this mapping, I can see a situation where I've got more than one line coming from an x number. Again, that means the x repeats. So it's pretty simple. The only thing we need to add to this relation function idea is we're going to start really using the concept of function notation more. We're used to having an x going into an equation and coming out with a y. So I'm representing x's with these cubes, and I'm actually going to do this a little bit later in a different section as well. And a cup as my y. In this case, I'm going to make y equal 2x plus 1. So previously, what we've been talking about is taking our x, plugging it into our y, and finding what comes out by taking 2 times that input plus 1. We're still going to pretty much be doing that, but instead of this y, we'll sometimes use it, but a lot of the times we're not going to use this y. We're instead going to use f of x. That's not saying f times x. Don't say f parentheses x. This is f of x, the function evaluated at x. I've kept it being 2x plus 1. But we're still talking about the idea of an input going into my function and coming out with an output. So whatever I plugged in, I'm going to have 2x plus 1. What I plugged in, I'm going to multiply by 2 and then add 1. So that's really all there is to functions and relations. So go ahead, continue on your lesson, do your practice problems, look at the examples, and good luck.